What have I got myself into this time?
Whether you're for or against AI, it's hard to deny that at least on the hardware and engineering side of things, that it's super interesting. I mean, sure, you can pay for a subscription to OpenAI or Google with Gemini for the privilege of spoon feeding them your data in exchange for some AI goodness, but you can also be like all the cool kids on the playground. Hell, even PewDiePie is doing it these days and run your AI models locally. Yes, even the computer or phone that you're watching this video on can run a large language model. But you know what can AI better? Not one, not two, but precisely 4 Macintosh, good for a combined total of 1.5 terabytes of unified memory to run the beefiest and absolute baddest large language models out there without having to give Daddy Altman any of our data. If you're a hardware nerd or you're into AI, get subscribed, duh. But you've also probably seen this before. But I promise you, there is something huge that's new. In fact, 2 things. This Mac Studio cluster should be multiple times faster than it was even just yesterday, all while still consuming less than around a half of a North American power circuit, and while realistically costing multiple times less than a solution that can run models in the same class as this. It's basically in a class of its own given the price and the capabilities at this point. It's kind of ridiculous. First is Apple's sneaky release of RDMA over Thunderbolt in the recent macOS 26.2 beta. You probably wouldn't think much of it, but that is going to enable most of the performance increases we're seeing today. And second, the public release of Exo 1.0. That's the software you can use to take 4 Mac Studios like this and turn them into the AI cluster of your frickin' dreams. But we're getting a bit ahead of ourselves here. See, if you've tried to run local LLMs and you don't have hardware this crazy, you've probably noticed that they seem, well, for lack of a better word, kind of dumb, or at the very least less intelligent than when you talk to ChatGPT or Gemini. Don't get me wrong, those small models have their uses. You can't exactly fit a Mac Studio amount of performance, or memory for that matter, in a security camera or a smartphone. It makes sense that they can't compete with the big services because the models that you're using when you work with ChatGPT are in the range of hundreds or thousands of gigabytes. So large that they need to run in data centers that cost as much as the GDP of a small European country to build, and realistically probably use more energy than those European countries too. But you can also run models of that size on these. Sorry, I'm just making space for my supercluster. I hope you don't mind. Who did this? Brother. You see, Apple designed their M series of silicon with unified memory that's shared between both the CPU and graphics cores, which enabled them on the launch of the M3 Ultra chips that are in these Mac Studios to release a SKU with a whopping 512 gigabytes of RAM, which is half of the units we have here. The other half have 256 gigs, both of which were enough to run some insane AI models. The kinds of models that are one-shotting code challenges, and they're only getting better, which is exactly why you, software engineer or total noob, should be checking out boot.dev, who sponsored this portion of today's video. They've cracked the code, if you will, on making programming fun and engaging to learn by basically turning it into a video game. I know it sounds crazy, but imagine this. You're learning to do back-end web development by learning Python and SQL and Go, and at the same time, you're earning XP, you're leveling up, and you're completing quests. Heck, you're even doing boss fights all while learning. They have courses for developers of all experience levels with a curriculum that goes super in depth while still being easy and engaging to follow. And their courses even teach you the tools of the trade while you're working through them. So you learn how to use Linux and Git and Docker. It's kind of crazy, but it's not as crazy as the fact that they give you all the course material, the lessons, the video tutorials, and the starter code on their website for free. So you can start to learn how to build a real web project without any risk to your wallet. And if their interactive learning style works for you like it's been working for me, then you should use code JACU to get 25% off an annual plan that gives you all of those fantastic interactivity features like hands-on coding, AI assistance, progress tracking, all the gamification for all of their courses at the link down in the description. It's genuinely freaking sweet. Love those guys. Like the 70 billion parameter Llama 3.3 model in full FP16. Let's see how fast that goes across one of our Mac Studios. Can you write me a 1,000-word story about how cool BMWs are. Include discussion of oil leaks.
Oh God.
Took about 2 seconds for the initial response, and we're running at a rate of about 5 tokens per second, which is not the crazy fastest thing out there, but it's not an easy to run model at 150 gigabytes on its own. But now we've got models like DeepSeek where they're 700 gigabytes, or Mistral 3 Large and Kimi K2 in excess of a terabyte in their full weights, which is crazy. But we can handle that with this setup. Right now I've got 10 gigabit Ethernet plugged into all of them, and I'm gonna boot up EXO on the rest, and it should automatically form a cluster for us, and then we'll see how much faster we can make this go just on the same model, and then we'll try one of the bigger ones. Die, my child. Now, if we start EXO on the rest of our Macs, now we have a cluster, baby. Even though we don't need the extra memory from the other machines, we can make use of the compute on the other machines and have that same 70 billion parameter model run way faster, at least in theory. Now, before we try all 4 of them, I'm gonna start by loading that same Llama 3.3 model on 2 of our machines and see how much of a speed up that yields on its own. And then we can go into rocking it on all 4, all right? Write me a 1,000-word story about leaky BMWs. Is it gonna go any faster? That is effectively the same speed. 2 seconds to start and 5 tokens a second. That's kind of weird, huh? We are running it across both of them. You can see that we've got 100 watts of power draw on each Mac Studio, and the model is spread across the memory of both of them. But what if we try and run it on all 4? Well, we're still talking about 5 tokens a second. What's the problem? Now you can imagine the data of our model as a book, and when we load that book across the cluster, each machine gets its own set of chapters, but it doesn't necessarily have access to the entire book. That means each computer has to calculate its response to your prompt with the chapters it has access to, and then pass that response, or the partial response, on to the next computer in the cluster before the next computer can even do anything. It's just like a relay race where you run your section, but you have to hand off the baton before the next person can start. Except for our situation, on each lap that the cluster completes, we only get 1 output token, which you can imagine is around 1 letter in the output. In our case, the racetrack is essentially the networking that we're connecting all these machines with. And you can see right now, we're just using 10 gig Ethernet with a 10 gigabit UniFi Pro XG8 switch, which I'll have linked down in the description along with all the other hardware we showed off today. That 10 gigabit networking is plenty enough bandwidth to transfer what is essentially part of a letter. Our hypothetical relay runners here are so fast that forcing them to talk over standard Ethernet is like the networking equivalent of forcing them to go through airport security every time they need to pass on that baton. So you can imagine when you're asking it to write a 1,000-word story for each letter within those 1,000 words, our cluster here is effectively going through TSA at least 4 times. That works out to a metric shitload of completely random searches, and why, in the enterprise, they use InfiniBand, which has much lower latency. Now you could already do better than this simply by using Thunderbolt cables directly connecting all the Macs together rather than using Ethernet with the switch. It's just a little bit lower latency on Apple's stack. Or we can bypass this hypothetical security problem entirely by using RDMA. It's kind of the same deal. We're gonna hook up all of our Macs directly with Thunderbolt, but then we need to drop into the recovery menu of our Macs and actually enable it. Now you do need the macOS 26.2 beta, and you have to be using a machine that has Thunderbolt 5. That includes anything M4 Pro or better, as well as the M3 Ultra. Now I'm gonna hook this up exactly as it says in the guide, which honestly is a little strange. How does this even work? So, this guy, how am I missing a cable? 1, 2, 3, 5. Where's the 6th? Spaghetti! They're all connected like that, woohoo. Now with 3 Thunderbolt 5 connections on each of these systems, we're talking about an aggregate connectivity from each of them of around 240 gigabit both ways, but we're not gonna make use of anywhere near that. The real story here is once we have RDMA enabled, the latency cuts down by 99%, which is huge. Hey Arlo, Do you like fast AI? Oh, boop. Got him. Now you see, we can take the same Llama 3.3 70 billion parameter model, select MLX RDMA and tensor sharding. Yeah, Arlo, hey, I don't even know if the RDMA is gonna work right off the bat. Who knows? Maybe I cabled it up wrong. The time to beat is 5 tokens a second. Write me a 200-word story. Holy shit, 9 tokens a second. That's almost double the speed we had running on just one. Whew, I'm a little bit in shock. That was a bit of a dumpster fire getting that all going. Okay, why don't we try something bigger, like the Kimi K2 Instruct model in a 4-bit quant?
Your what? My quantitative.
540 gigabytes. For a baseline, I'm gonna start with the standard pipeline MLX ring sharding so that we get a good idea of what it would be like before we use RDMA. Once we know how fast that goes, we'll try it with RDMA. This is so freaking cool, man. I'm excited to try the new Mistral models for coding because they apparently are like,
Nice.
I suspect it's not gonna go too fast, but we'll give her a shot. Oh yeah, okay, look at that. This is over Ethernet right now, but it's only transmitting like 20 megabit, 25 megabit. That's it. And we're getting around 22 tokens per second. I'm Uncle Jim and I hate oil stains the way cats hate bathwater. Now, let's try RDMA and see how fast it actually goes. Oh, and then it crashed, it seemed like. Fast forward, oh my God, like 12 hours of troubleshooting and messing about trying to get this setup to work as I was thinking it should work, and it seems like we're finally there. It wasn't just my changes, they actually have made something like 40 different version updates in the last 2 days just to get this working a little bit more stable. We're definitely at the frontier of this technology. There doesn't really exist another solution for this, as Jeff Geerling so nicely highlighted in his Framework Desktop video. I also found out that because my Macs were named differently than they asked, they were expecting them to be named as the cabling image said. In the future, that's a limitation that should disappear, but since this is like definitely tech demo territory, there's some weird quirks with it like that. I also am not able to upload any of my own custom models into this setup. It's very much a set of models that they have pre-curated and determined work properly with this setup. They also have to be models that are in the MLX format for this to work properly on Apple devices with RDMA. However, now we can see how fast this, you can fit so many AIs in this bad girl right here, I tell you what. And same with this one, and that one over there, and this one over there. As I showed you guys before, one of these Mac Studios with Llama 3.3 70 billion parameters in the FP16 weight that I've been using takes about 2 to 2.5 seconds to start and goes around 5 tokens per second for inferencing. However, when we run it on 2 of our Mac Studios with tensor sharding over RDMA, well, that jumps up to more like 9 tokens a second. However, it's worth noting that that is a dense model, and that means we get really good scaling, even though it seems kind of counterintuitive. And there you have it. We're up to just over 1 second to get started and around 15.5 tokens per second. 3.25 times faster. How about Kimi K2? I talked about that a bunch. Well, in the Instruct version of it in a 4-bit quant, well, you can't actually run this one on just one machine. Even at 4 bits, it's nearly 600 gigabytes. So our baseline is gonna be pipelining the model over 2 of the machines. That's essentially the same results we saw before when we were on just Ethernet, and that yielded about 25 tokens a second. And then when we split it across all 4 machines, nearly 35 tokens per second. The scaling is nowhere near as good as a dense model, but it is still a large performance increase, and it does also show that the time to first token going from around 6.5 seconds down to 1.5. That's the kind of latency your users or whatever have to wait for before they even start to see a response. The problem is those models move around a lot in their total parameter pool, which means they do a lot of smaller calculations, at least relative to a dense model, and that adds a lot of overhead, at least in the current software setup. Now, the EXO guys say they are working on optimizing this, but I expect, based on what they briefed me with, that the results we see on those are not going to be anywhere near as good. But it's kind of hard to complain, because what's your alternative at this point? I guess you could buy like 8 NVIDIA DGX Spark units, but then it would draw way more power. You would only have the same amount of VRAM as one of these Mac Studios, and it would cost
$32,000.
Let me show you what I mean, starting with DeepSeek 3.1 in an 8-bit quant running on 2 of these Macs. For some reason, it doesn't have the option to run this model pipelined across multiple, just for the VRAM improvement, not for any performance improvement. So I don't have a comparison point less than this, but we can at least try 2 versus 4 in this configuration and see what that looks like. Here's what I'm talking about. DeepSeek v3.1 with 671 billion parameters total only has 37 billion parameters actually active when you're inferencing. It's like 5% only. It took 3.5 seconds for us to get the first token, and it's going at around 20 tokens per second. Now let's boot it up on all 4. See what I mean? Instead of our pretty linear scaling that we were seeing before, we went from getting 20 tokens a second to getting 24 tokens a second. Sure, the time to first token dumped a lot, from 3.5 down to under 2. But you can see how much less efficient it is to parallelize these mixture of expert models than it is to parallelize a dense model, at least for now. So clearly the performance is pretty awesome, and with future optimization, in theory, we'll be able to get even further on the same hardware again, which is so cool to think about. However, what do you use this for, right? Because if you're using those fancy OpenAI models or Google models or Claude or whatever, you can use them with Claude Code, you can use them in Cursor, you can use them in VS Code. However, we don't really have that infrastructure for this setup. Fortunately, EXO does provide an OpenAI compatible API that you can interact with your models with directly, even when you have multiple loaded. Now, that was something that didn't work when I first tried this, and after their bajillion updates is working a lot better, so you can have more than one model loaded at the same time. However, I tried a bunch of different AI coding agents, and none of them seemed to talk to it properly. OpenCode was the closest I got where it actually was giving me good responses. However, the tool use just like didn't work at all. The EXO guys told me that they're working on that or whatever. I mean, you can at least use it in Jan, like, hey, generate me a website. And I mean, it does. It even says you can just copy paste this, bro. We can just take this and paste it into a website and then open it up and subscribe to my YouTube channel, duh. Wait, why did it pick Ludwig? What the Oh, I wasn't subscribed to Ludwig. But I wanted to like go directly into a file or read files and have that context, and it's just not quite there yet. You know what I'm interested to see though is how much power it's actually drawing during this. So let's ask it to write a much longer story. It's drawing around 115 to around 125 watts. Put that all together and we're at around 480 watts for a mixture of experts model where it's really not making perfect use of all that hardware. Let's switch back to Llama for a second and see what the power draw is like when we're running that, where it actually like really can make good use of the hardware. So much, oh, it failed. What?
It's delusional.
They're using some like very beta features that Apple added to sync the CPU and GPU when running an MLX model like this. And apparently it's not the most stable thing in the universe. So I'm gonna close EXO on all the machines, start it back up again, and then we'll try. Oh, that's wadding up the hoo-ha. That's a weird thing to say. With dense Llama 3.370 billion, our power draw is more like 600 watts. That's actually less than one H200 NVIDIA GPU. Can do around 50 tokens a second on one H200 at FP8 instead of FP16. So half the size of the model. So why don't we try that across our cluster? Now for reference, an H200 is somewhere in the neighborhood of 30,000 US dollars. Yup, 26 tokens a second. So we're just about half. It's just really cool to be able to see what we can do with existing hardware and a little, or frankly, probably a lot of software optimization. This is the same hardware you could have bought all the way back in March of this year, and now it's getting this much performance uplift. It's really, really freaking cool. I'm not gonna lie and say there isn't a part of me that goes, I wish the reason we were pushing for optimizations like this wasn't for something that so many people use for bad stuff, but I've been trying to reconcile in my head that just because there are bad things that people do with AI doesn't mean there isn't also good things. My first thought when they offered me the opportunity to try this setup out was, dude, I should use this to replace my Alexa and build like frickin' the most insane home voice assistant ever. But unfortunately, the apps that are out there for connecting Home Assistant to an OpenAI compatible API just didn't seem to work for me. So I don't know. How about get subscribed? Because I've got these for like 2 more months, and that means I can spend some time making that work, and then maybe I'll just have to buy a couple. I mean, I don't need to run a 700 gigabyte model for my voice assistant, but... And while you're down there, don't forget to check out boot.dev, who sponsored this video. It's a fantastic tool to gamify learning how to code. You can also hit the like button while you're down there and comment. Let me know what you would do with this much absolutely ballin' compute.